Good evening, my dear student. Now I will discuss bijective function. Previous class I also discuss one mapping or one function, onto function, into function, many one function. Everything I had already discussed. Okay. Now I will do application. Okay. How to do application of bijective function. Okay, see, bijective function. Okay, bijective function. Let f of x equal to 2x minus 5. X belongs to R. X belongs to R. This is given. Okay. Just you have to write let x1 and x2 be any two elements of R. That is, x1 x2 belongs to R. You have to write. So first write down f of x1 equal to f of x2. Okay, so we can write, see, 2x1 minus 5 equal to 2x2 minus 5. So 2x1 equal to 2x2, that is x1 equal to x2. Okay, we are getting x1 equal to x2. So here we can write f is 1 1 function. 1 that is 1 means injective function. Okay, first, so given f of x equal to twice x minus 5 is given, you have to consider first x1 x2 be any two elements of R. That is x1 x2 belongs to R. So we can write f of x1 equal to f of x2. So 2x1 minus 5, put this value here. This value is given. 2x1 minus 5 equal to 2x2 minus 5. So 2x1 equal to 2x2. So x1 equal to x2. We are getting, see, one relation is there now. Here one element, if we consider two sets A and B, the element x1 belongs to A and x2 belongs to B. So one set to another set relation is there. So x1 equal to x2. Okay. So here f is 1 that is injective function. Let y be any element of R, any element. Okay, any element of R. So here y you have to consider some codomain of R. Suppose codomain of R. So you can write y equal to 2x minus 5. Okay, see, y equal to 2x minus 5. From here we can write y plus 5 equal to twice x. So x equal to y plus 5 by 2. Okay, see, y plus 5 by 2, this function, this one, we can see belongs to R, no? Real number R. Okay, R. So for all, so you have to write, 1 minute. So you have to write for all y belongs to R, y belongs to R, there exists x equal to y plus 5 by 2, this value, whatever you have got, okay, which belongs, this belongs to also R, this belongs to R, where f of x equal to y. Thus every element in R codomain, that is codomain has its pre-image in R domain. Every element in R, that is codomain, has its pre-image also in R domain. See, just give an example. Suppose here also both are R. Given this is R, here also R. That is, relation is function f R. So here f R to R, this is given. This R here codomain, here domain. This is x, this is y, this is x, this is y. Okay, see, every element in R, this is codomain, has its pre-image. Here pre-image, every element of R has pre-image, here also pre-image. Okay, so in that relation, because x belongs to R, this consider here also R, and previous time also R. This is the relation. Okay, again I am giving another sum. See, suppose, see, f of x equal to 3x plus 1, x belongs to n, natural number. See, here f n to n, both are natural number. See, both are natural number. Okay, similarly, let see, both are natural number. Let x1 x2 belongs to n. Say f of x1 equal to f of x2 implies 3x1 plus 1, 3x2 plus 1. So that is x1 equal to x2. See, so f is 1 1. Okay, all of you understood? Yes. Now that is f is injective function. Okay, again let y belongs to n. So you can write y equal to 3x plus 1. So y minus 1 equal to 3x. So x equal to, we can write y minus 1 by 3. See here. Okay, x equal to y minus 1 by 3. See, we can't say this belongs to n for all n. Okay, for all y belongs to n. See, here we are showing the y n for all values of y. So it will not be a natural number. Okay, it is not a natural number. Fraction is that y minus 1 by 3. So we can't say it is not surjective. It is not onto. So it is not onto mapping or onto function. So we can say f is not bijective function. Okay, it is not bijective. Again, another example I am giving. Say suppose let's set A r minus 2 b r minus 1. A relation f a to b, this b is a function. This is given, function is given. So this is function is given. So f of x is given x minus 1 by x minus 2. Then prove that f is invertible and find f inverse x. Very important question. This is very important question. Okay, here is given a equal to r minus 2 means in real number we are not considering r equal to 2. We are considering similar also not considering r equal to minus 1. Okay, no, sorry, y equal to 1 here, 1. Not considering y equal to 1. So f of a, one function is given, f of x equal to x minus 1 by x minus 2, to prove that f is invertible and find the inverse of x. So what is invertible function? First considering a function which is 1 1 on 2, that is bijective function, is also called invertible function. Then first we have to prove bijective. Okay, first we have to prove bijective function. How to prove bijective? Similar way you have to consider. Okay, see, let x1 x2 belongs to two elements of A. So let x1 x2 belongs to A, elements of A. So write f of x1 equal to f of x2. So we can write x1 minus 1 by x1 minus 2 equal to x2 minus 1 by x2 minus 2. You have to cross multiply it. See, x1 minus 1 into x2 minus 2 equal to x2 minus 1 into x1 minus 2. Okay, then you have to multiply it. So you multiply it, you will get, suppose x1 equal to x2 will get. Okay, x1 equal to x2. Okay, which belongs to A. We know for all x1 x2 belongs to A, that is the real number. C are less than 2 minus 2. So x1 equal to x2 for all x1 x2 belongs to A. Understood? Yes. Now, so we can say f is 1 1 1 1. F is 1 1. Again, let y belongs to B. Another element, B is the two sets, B is there. So let y belongs to B. Okay. Then we can say f of x equal to y. Function y is the function of x, we know. So y belongs to B, then we can write y equal to f of x. Okay. So write y, fx value we know, though, just put value here. So we can y equal to x minus 1 by x minus 2. So cross multiply it. Okay. So you have to cross multiply it. We get 1 minute. So y, you can say x minus 1 by x minus 2. Okay, so right, xy minus y equal to x minus 1. So one side you take, find the value of x. So x common, y minus 1 equal to y minus 1. Okay. Wait. 1 minute, sorry, x minus 1 by x minus 2 is there, okay, by mistake I wrote x minus, so this is 2, okay, so xy minus 2y, x minus 1, so x common y minus 1 equal to 2y minus 1, 2y minus 1, okay, so x equal to 2y minus 1 by y minus 1. See, so this one, we know x belongs to A, so we can write this part. So for each y belongs to B, for each y belongs to B, there exists x equal to 2y minus 1 by y minus 1, which belongs to A. X, first you consider x value here. We have got see x equal to 2y minus 1 by y minus 1, here y not equal to 1, okay, so x equal to y minus 1 by y minus 1 belongs to A. Now see, now we have to prove onto function, okay, here onto function we have to prove. See, look at here, we know f of x, so you can write f, the value of x we got, no, see this value we got, we put the value 2y minus 1 by y minus 1, okay, now you can write, so fx equal to, we know the value f of x, first consider f of x is given, we know the f of x equal to x minus 1 by x minus 2. Previously we know the f of x equal to x minus 1 by x minus 2. See, suppose this is fx consider, this is f of x, x, look at here, x, you put this value x minus 1, so you can write 2y minus 1 by y minus 1 by x, that is 2y minus 1 by y minus 1 minus 2. See, this part understood or not? This part understood or not? Okay, this part understood or not? Just put the value, so you'll get answer y, you'll get y. If you simplify it, you'll get y, okay, y. So you can say f is onto function, f is onto function, f is. My student, see, in previous class up to this we have proved f is one function, and first we have already proved that f is 1. See, f is 1 and onto function, okay, onto function. So we can say f is invertible function, okay, invertible function. See, since it's invertible, so we can write, look at here, inverse exists, so you can say inverse exists, okay. See, so you can say that is inverse, if inverse exists function, okay. So you can write y, we are getting x equal to, see, 2y minus 1 by y minus 1, already got this one. So you get a in like that, this form, y equal to 2y minus 1 by y minus 1, okay, y minus 1 for y belongs to, for all y belongs to B. See, all y belongs to B, okay. So we can write f inverse x equal to 2x minus 1 x minus 1, in terms of x you have to write. This is inverse function. From here, suppose you put find f inverse, suppose 5, then you put x equal to 5. Suppose F inverse 7. You put 7. Suppose F inverse 10. Suppose F inverse 10. Okay, find out. Then I put x equal to 10 like that. Okay, so this is the answer. Okay, okay, bye.